So this is day 5, and we're looking at problems 1, A, B, C, D. And we're starting with the easier one first. We're multiplying by a common denominator, as suggested by Patrick. And the common denominator is 3n plus 1 times 6n squared plus 1. We can multiply by 1. So we multiply top and bottom by 6n squared plus 1. We can multiply this by 1. 3n plus 1 over 3n plus 1. Great. But now we have to multiply those. So the limit as n approaches infinity, 6n to the 4th plus n squared minus 6n to the 4th, n cubed times n is n to the 4th, minus 2n cubed all over, let's multiply it out. 12n to the 3rd plus 4n squared plus 3n plus 1. Does anything nice happen first? All right, so there you go, -1/9. -1/9. Does that make sense? And that's common denominator. I'm just using that divide by the greatest power of n. Well, that one is a difficult one. You might see 1 as difficult, but it's not too bad. We look at two conditions when n is even and when n is odd. Okay, so let's look at when n is even, like 2, 4, 6. Won't this just be the limit as n approaches infinity? If this is even, won't it just be 2n minus 1 over n, right? And then if it's odd, it's going to be the limit as n approaches infinity. -1 times 2n is -2n plus 1 over n. Well, what's this limit equal to, this top one? 2. What's the bottom one equal to? -2. So since they're different, what you would say is since limits n approaches infinity of u of n odd is not equal to the limit n approaches infinity of u of n even, the limit does not exist. Ooh, I like that one. Try B and C. See what you come up with. Did you have a question? Well, when it goes to infinity, you want it to go to 0. That's proof that you want all those alternating ones to go to 0. Because if they go to 0, then it doesn't matter if they're even or odd. But if they go to infinity and the odds are 1 and the odds are another, then they can't, they'll just be doing this forever, which isn't a limit. Yeah. Yep. So anything less than 1, this is going to go to 0. You can do this a number of different ways. Integrated form, you could also, what I would do is I would look at this is a geometric infinite series. Yeah. This goes to 0. And what does this 1 over 10 to the n, what's that going to do? 0 as well. So you're just left with 0 over 1 plus 0, which is what? Is 0 a limit? Yes, it is. 0 is a limit. Infinity is not a limit, but 0 is. Yeah. This one here? Interesting. One more on this page, C. With C, you're taking the limit as n approaches infinity of the square root of n plus 5 minus square root of n minus 1. Now, this is infinity minus infinity. Is that an indeterminate form? It is. So there's something we could do, and that something is to multiply top and bottom by something. And what's that something going to be? The conjugate. The conjugate will give us something wonderful in the numerator and square root of n plus 5 plus square root of n minus 1 in the denominator. N plus 5 plus square root of n minus 1. So when we multiply those out, you're going to get square root of n plus 5 times square root of n plus 5 is n plus 5. Then you'll have a positive product and a negative product added together. These will cancel out those. So then you're going to get negative square root of n minus 1. Square root of n minus 1 is n minus 1. All over square root of n plus 5 plus square root of n minus 1. Now what? What do we do next? Anybody see it? Yeah, these n's are going to go. N minus n. So you'll have the limit as n approaches infinity of 5 plus 1 is 6 over the square root of n plus 5 plus the square root of n minus 1. And when n goes to infinity, you get 6 over infinity, which is about what? 0. 6 over infinity, which is 0. 0 could be a horizontal asymptote. It could be a value, could be a number of different things. But that's the limit of that. So what we did, some really nice overviews of some odd but useful little limits. Common denominator, conjugate, break up even odd for an alternating, and do the, think about the infinite series. Well, you try number 2, and I'm going to ask you, make a sigma for this one, n equal to something to infinity, and you're going to have some formula in here. Then find this convergence using what? Ratio test, and then check the individuals. Great practice there. And then I want you to take this integral general form. You don't have to find C. Leave it in terms of C. Give those 2 a try.